Over the last couple of years, there's been a major shift in cybersecurity known as the shift left. But what does shift left actually mean? Well, according to Google's Search AI overview, in cybersecurity, shift left security is the practice of moving security measures to earlier stages of the software development lifecycle, or SDLC. This involves integrating security testing and focus areas from the very beginning, allowing developers to identify and fix vulnerabilities and coding errors as early as possible, thereby preventing security issues from reaching the final product. That's a mouthful, but let me explain it in more plain terms. You see, previously, in traditional software development, your software is typically built on physical servers in data centers. You would typically manually acquire the servers and then install them yourselves or have your data center technicians do it for you. What this meant is that you had full control over everything, including the most up-to-date versions of all the components of your server and your deployments. But now, things have actually evolved into a different level of abstraction where you're now using container images that come with their own level of complications. With container images, you cannot always be sure about the contents of these containers. They come pre-packaged and oftentimes come from third-party registries that we just typically have to trust. But as any seasoned or even novice security professional will tell you, it's always better to trust but verify, or sometimes not trust at all. So amidst this evolution, we encounter concepts like DevOps and DevSecOps, which embraces this shift-left approach by integrating security into the continuous integration and continuous delivery pipelines. For developers like you, if you're one of them watching this video, this means you can easily ensure that your software is being securely developed and shipped from the start. For cybersecurity engineers like myself or other cybersecurity engineers watching this video, this means you're going to be focusing more on software security or DevSecOps, and this will include providing, configuring, implementing, and maintaining solutions that help developers ship software securely. So to bring all of these worlds and things together for both developers or cybersecurity folks, in today's video, I'll be showing you how to securely containerize a simple Python application. We'll compare a regular Docker image to a more secure one and discuss why you should be using ChainGuard, the sponsor of today's video. So whether you're a DevOps or a DevSecOps or cloud security or software security or even a software engineer, you definitely want to check this out. ChainGuard is one of the leading solutions in this space. It focuses on securing the software supply chain by providing hardened, continuously updated, and maintained container images. Of course, there are different container registries with official images, but ChainGuard provides a much safer and secure choice. Thanks to ChainGuard for sponsoring this video and making software supply chain much secure. With that being said, let's get started with this Python application. All right, so let's start by creating a directory on our desktop where our main local files will live in. So I'm just gonna change directory into my desktop, and then I'm just gonna make a directory called ChainGuard, and then also just change directories into that particular directory. All right, cool. That is a empty directory. So while I was testing this, I actually created a repository where I have a couple of configuration files that we'll be using to test out everything we're going to be doing today. And it's just going to have a couple of infrastructure code and config things to automate the entire process and make this thing super repeatable and easily configurable for anyone who wants to try this at home. So let's go ahead and navigate to that repository on GitHub. And here is that repository. If you go to my GitHub and just look at ChainGuard-demo, it would be there. I'll go over what's inside the repository in a second, but let's just go ahead and grab that repository and we'll just copy that and then go back into our terminal and we'll just do a git clone, grab that, and we're doing ls, we should see that directory there. If we cd into it, we should see we have the ChainGuard and instance CloudFormation one. Now locally, the particular folder that we actually care about is the instance CloudFormation one, because that's the one that's going to allow us to create the instance that we're going to be using Docker on. So let's actually go into VS Code and look at that. And what we care about locally, like I said, is this CloudFormation template I created. So let's take a quick look at it and what's going to do for us. So I created this really straightforward template, and what it's going to do is first it's going to have input parameters for your SSH IP, which we're going to use to access the instance via SSH. And the reason why I'm not hard coding this is because I want to pass it through the command line when I'm actually deploying the instance. Then the next section is the infrastructure. This is going to be a simple EC2 instance security group. It's going to have SSH access from my IP address, which it would reference from this parameter, and then the actual instance itself is going to be a regular Amazon EC2 Linux, which is going to be denoted by this particular image. And then I'm using the T2 medium because there's a part of the demo that I'm going to show that has a little bit of like workload intensity to it, and I need a little bit more RAM, and T2 micro is just not doing it for me. So T2 medium is going to be the best. I already have a key that I use for testing stuff, so if you don't have a key pair, definitely create one and then download it. But in this case, I'm referencing this key pair I'm using here, which I already have in my AWS environment. And then for the security group that this instance is going to use, it's going to just reference or get the attribute of the group ID from this during deployment. And then finally, I created this very simple user data script upon deployment that would install a couple of things and make that process a lot more easier for us, so we don't have to like do it post instance deployment. So basically it's just going to update the instance. Afterwards, it would create a Docker group and then modify that group to add our Ubuntu user for that instance into that group, and then reboot the instance before allowing us then SSH into it. And then finally, we're going to have the output parameters for the instance IP address to be accessible to us, because we're going to need that to SSH into it from our local terminal here. So what I'm going to do is just going to open a terminal here as well, just to make it easier, and it should open right there, which is just perfect. So what we're going to do now is we're going to actually deploy this instance using CloudFormation and AWS CLI. I'm not going to go over the AWS CLI configuration process. It's a very straightforward process. I have a couple of AWS videos where I go over it, AWS configure profile, all of that, but it's a fairly straightforward process. You can take a look at it on AWS documentation. So in order to create the CloudFormation stack we're going to use to deploy this instance, we're going to say AWS CloudFormation create stack. And you can see I already have the command listed out there because I ran it a couple of times. But create stack, and then we're going to specify the stack name. So tag stack name, and specify the name of the stack, which I'm going to name ChainGuard demo. And then we're going to tell it what template we want to pass. So the template body is going to be file : / Since we're already within the ChainGuard folder here, which we probably shouldn't be in actually. So I would have to actually stop that and do an ls. I need to actually change directories into the ChainGuard demo folder because I did a git clone on that. And then, all right, perfect. So we can then run that create stack command. So again, it's going to be AWS CloudFormation create stack name, and then ChainGuard demo, and then we're going to specify the template file or template body to be file : / So the folder that has the template is this instance CloudFormation folder. So we'll just say instance -CloudFormation /ChainGuard -template, which is the name of the YAML file that has the template we just went over. And then since we're going to be passing our IP parameters there, I'm just going to just do -- parameters, and the parameters do a key value sort of methodology here. So we're just going to say parameter key is equal to my IP address, and the reason why we're using that particular key is because that's what we called it here, so it already knows that. And then I'm going to say comma parameter if I can pronounce that word properly, value is going to be, so I use my IP address CIDR range, so I'm going to put that in here. It's going to be blurred out, but just use your IP address CIDR range, so like the IP address / whatever / it is that works for you. And then I'm going to specify the profile that I want to use to run it. I still have my nice and handy Havoc profile. Real ones know where that profile is from. So we're going to use this command to create that stack. Now we get back the results of the ARN or the resource name for that stack. What I'm going to do next is I'm going to run a AWS CloudFormation wait stack create complete, and then specify the stack name to be our ChainGuard demo stack, and then again profile Havoc here. Now this command, what it does is it waits for the stack to complete, which it already did. It was pretty fast here. It waits for the stack to complete, and it wouldn't, it would leave the terminal open until the stack creation is complete. In this case, it was pretty fast. So we can actually confirm if the stack was actually, created by doing a AWS CloudFormation describe stacks, and then just say stack name ChainGuard demo. And I should probably move my base to prevent it from blocking the view. And there we go. Yeah, so it's going to be ChainGuard demo. I'm going to run that, and it should give us like a JSON output of that stack. Oh, I have to specify my profile. So I'm just going to say profile Havoc, and should give us a nice output. Yeah, there we go. So it gives us like a JSON output of our stack, and we see the stack status. We see the stack status as create complete. Now, if we scroll down, we have a couple more details. The output that we requested within the template right here was the public IP address of that instance, because that's what we're going to need to use to SSH into that instance using our SSH config file. And that output value is this public IP address 54.166.142.44. There's also a really cool nifty way you can actually pull that output from the stack output without having to first describe the stack and like that. So it would just be like this, and then I'm just gonna go back a bit, and then I'm just gonna say ChainGuard demo, and then dash query, and then open a quote. And this is where we're just gonna use like JSON output to get it. So we'll say stacks, and the first object in there, outputs, and within outputs, we're looking for output key equals instance public IP, close that quote, close that square braces, and then output value. And then we just want to tell it to output that text and then specify our profile as Havoc. And it would just give us that IP address. It's pretty much the same thing, but just a really cool way to get that detail. All right, so now that we have our IP address, we can just copy that. We can just queue to quit that. And then we have to update our SSH config file. I should be able to find it by going into my file, open recent, and it should be this, or you can easily actually get it by going down here and then going into open SSH configuration file, and then this particular file here, and then I can update this IP address with the new IP address that I have for that instance. I'm just gonna name the host ChainGuard, and then the user we're connecting as is Ubuntu, which is because we're using the Ubuntu instance and it's a Ubuntu username. And then finally, the identity file is this SSH key, which we already have downloaded here, and I already saved it here. It's a fairly easy thing to set up. I'll leave a link in the description to a guide that can show you how to quickly do this, but it's fairly easy to set up. So what this will let us do is this will let us to, if we clear this, do a SSH ChainGuard, because we specify the name of the host that has this configuration as ChainGuard. So let's just do SSH ChainGuard, and I should actually have checked if the deployment was complete because it takes some time for EC2 to initialize, but I'm gonna say yes here. I think it's all ready. All right, perfect. It looks like it's all ready. So it looks like we're in our Ubuntu instance, and if we should do a Docker version here, it should give us details, which is pretty good. It means that our user data configuration script worked as we desired. So let's go ahead and start getting busy with actually understanding how ChainGuard works and comparing different images and seeing how the security of these different images are in terms of vulnerabilities and all that fun stuff. Now, before we go to the next section, it's worth noting that the tool we're going to be using to test these different images, whether they're from Docker or from ChainGuard or whatever registry they're from, is Docker Scout. Docker Scout basically analyzes the image contents and then generates a detailed report of packages and vulnerabilities that it detects within the image. So this way we can easily identify if they're like high, critical, medium, or low vulnerabilities that are associated with a particular image. And this lets us know like how secure this image is or how many CVEs this image is associated with. And then later on, we're actually going to do a little bit of a comparison between different images to see how the images from like Docker Hub, for example, compare against the images from ChainGuard. That being said, let's go ahead and set up Docker Scout so we can actually use it. Now, the first thing we'll need to do to set up Docker Scout or to even use Docker Scout or anything like that is to do a Docker login. So I'm just trying to like clean this up, dragging it up there so it's much easier to read. So we're just going to do a Docker login. I'm going to close this sidebar as well. And then I'll put in my username. And you actually have to have a Docker account in order to do this. So you can easily create one at hub.docker.com. It's a fairly straightforward process of just creating a Docker account. But I'm going to then enter my password into this here, and boom, I am successfully logged in to Docker Hub from here. So the reason why we're actually needing to use Docker Hub or Docker ID for this is because Docker Scout is actually somewhat connected to Docker Hub. So that's why I have to log in before we can actually use Docker Scout. Now, for reference here, you can see there's a Docker Scout quick start, and there's also an installation doc as well. I'll leave a link to the Docker Scout docs in the description so you can easily access it. In order for us to actually get the latest version of the plugin, we use this command. And for more context, Docker Scout plugin comes pre-installed with Docker Desktop. We don't have Docker Desktop right now, so we're actually going to have to install it using this. So we're going to do the curl first and basically curl in a bash script from the Docker repository for Scout CLI, and then it's outputted in the file as this bash script. So we can actually look at the script by doing a cat install Scout, and then we can see it has a bunch of configurations, a lot of things that it's doing. You probably should be reviewing this before running it, but essentially it just helps you install Docker Scout. So in order for us to actually run the script, we're going to do sh install scout.sh, and it will run that command and then install Docker Scout for us within this particular repository. And now that we have that set up, we can actually run the Docker Scout command. So Docker Scout, and we can see it has a bunch of different things you can do. There's an attestation, cache. We're going to be using the compare. We're going to be using CVEs. We're going to be using quick view as well, and a bunch of other things. So let's actually do a quick view. Quick view does like a quick overview of an image. A very common Docker image is the Nginx image. So we can do a quick view of the Nginx image with Docker Scout. So let's say Docker Scout quick view Nginx, and let's do the latest tag for that. So Docker Scout is going to take a quick scan at that image and give us some details about it. All right, so we have a few details about this image. So the updated base image is a Debian stable slim. It has 0 critical, 0 high, 0 medium, and 23 low vulnerabilities within it. The base image has 23 low, and then the target image, which is the latest one here, it has 1 medium vulnerability, 48 low vulnerabilities within it. Now we can also also view the actual vulnerabilities that exist within this image. Let's copy this command and just do a docker scout CVEs Nginx latest. All right, so this gives us a bunch of details back, and if we look through these details, I'm gonna move myself down here a bit. There are a bunch of vulnerabilities here. I think we had a couple like that it showed us in quick view, but it gives you more detail about each vulnerability. So for example, like this is one low, and then it gives you a bunch of details about the vulnerability, gives you workarounds as well, like how to fix the vulnerabilities as well, with all these very, very long scripts. So that's a more in-depth view of the vulnerabilities, and then we can also get some recommendations on how to like fix the issue with Docker Scout. But we're not going to look into that now. We're going to look into what happens when we use ChainGuard in this example. Like what happens when we actually use a more secure image. So in order for us to do that, we can navigate to our browser and go to images.chainguard.dev. And this is where we can search up ChainGuard's images. Since we're just testing out Nginx for now, let's just do an Nginx and search that up. And we can just go ahead and use this command to pull ChainGuard's Nginx image. So we're going to copy that and head back into our terminal here and just do a Docker pull for that particular image. It's fairly quick. And let's do a Docker images to see what images we have here. So we have the ChainGuard Nginx image. I didn't pull the actual original like Nginx image, so I'm actually going to pull that Docker pull Nginx latest because I only just did a quick view on it. So we can do a quick comparison on it after this is completely done. All right, perfect. We do a Docker images. We see the normal Nginx, which is 188 megabytes, and we have the ChainGuard Nginx, which is the 22.1 megabytes, much smaller. All right, let's do a Docker quick view, a Docker Scout quick view on the ChainGuard image. We'll just say ChainGuard/Nginx, and that should give us a quick view on the Nginx image. And that was super fast. So we see with the Nginx image, we have 0 critical, 0 highs, 0 mediums, 0 lows. So basically comes with no vulnerabilities at all, at least according to, Docker Scout's detections. We don't even need to, do any further review on it. But obviously this comes, already secure because it comes from ChainGuard. Right, and we can see it's much smaller, even more lightweight than the Nginx image that Docker actually has to offer. So that's a quick test that we were able to do. We can also do a Docker Scout, compare Nginx, which is the Docker Nginx, the regular Nginx, tag to ChainGuard Nginx, and this will give us a comparison between these two. I want to pass that output to a file that we'll call image compare.md because it typically comes like in a markdown format. So let's do that, and then if I do an ls, I should see that image compare md file, and I can just do a cat on that file, and then we see if we just go all the way up here again, it's just the same thing we saw earlier on. Let's actually just do cat that and then just do a head on it, and we can just see comparison. Let's do a head 30 on that, and we see it does an overview of it, and we can see like the analyzed image, which is the normal Docker image, is having those vulnerabilities that we talked about earlier on, and then ChainGuard's image has no vulnerabilities at all. It's much smaller, right? It has fewer packages and comes even more secure. Now there are more details in there, but I can leave you to play around with that. Now we've done a very simple analysis here with 2 Nginx images, and we could easily just stop here and just be like, oh, ChainGuard's great and all, but I wanted to do something a little bit more fun. What about we build a very simple cybersecurity-esque application that shows us some cool and random cybersecurity quotes? I mean, this is a good way to learn how to Dockerize an application, a simple application in this case. And I actually feel like I'm going to be using this application for future projects and, actually developing it a lot more after this. But I thought it'd be really cool if we just create a simple Python application, Dockerize it, and then compare the new images when we use a normal Docker image and then when we use a ChainGuard image for the application, the exact same application. So that being said, all that rambling and all done, let's go ahead and create this application and look at its images and then compare it when we use a normal Docker image and then when we use a ChainGuard image for our Python application. All right, in order for us to do this comparison, again, I made this process a lot more easier for everyone. So within that repo that I showed you earlier on, there is a folder called ChainGuard, which has a couple of files in it. Let's quickly clone that repo again within our EC2 instance. Gonna navigate back into the web browser here and grab the link to it, navigate back to VS Code, and then clone that repository. All right, if I clear screen, do an ls, I should be able to chain my directory into that ChainGuard demo file, do an ls, and I see I have ChainGuard in there. So I'm gonna cd into that ChainGuard. Now within this, we have 2 folders. The first folder is cyber quotes normal, and the second folder is cyber quotes secure. let's first take a look at cyber quotes normal. If I cd into cyber quotes normal and do an ls, there are 3 files within it. There's a Docker file, there's an app.py file, and there's a quotes.txt file. Let's first take a look at the app file. If I do a cat app.py or app.py, it's a simple Python app, and I listed the sources here. I got 2 sources for some quotes. Importing the random module, creating a function called random line that takes a text argument, and then opening that text file, reading that text file as file, and then creating a variable called line, which will read the line or whatever line within that file, and then return a random choice of lines that is stored within that variable. Finally, we have the main function, which basically just prints out the output of the random line function, and then calling the main function down here. Essentially, this is a simple Python script that generates random quotes from the quotes file and then surfaces them to us. Let's also take a look at the quotes.txt file. In here, I have about 105 different quotes I got from the sources I listed up here, and basically just a bunch of cybersecurity related quotes, the author, and what they do. So you have a bunch of interesting cybersecurity quotes. It's able to generate random quotes from here. I plan to actually make this a web application that actually, every time you reload it, it generates a new quote and shows you on the screen. That would be really cool. But that aside, we can see that that's the quotes file it's reading from. Now, finally, we have the Docker file. Let's go ahead and do a cat on that Docker file. And Docker file is very, very simple. What it's doing is it's essentially just saying from this Python image, this specific image as our base image, as our parent image, set the working directory for the rest of the commands. So we have 2 commands that we have here, copy and entry point. But we want the work directory that's, basically coming from to be this cyber quotes normal directory. And then next, we're using this to copy the contents of this working directory into the image that we're running, right? And then finally, the entry point tells Docker how it should start the container. Basically start the container by doing Python and then running that application, that app.py file in there. And that essentially is the gist of the Docker file. So go ahead and clear this. In order for us to actually use this container or this Docker file, we have to build it, right? So in order to do that, we're going to do a Docker build and we'll specify whatever is within this particular directory by using a period. It's going to leverage that Docker file. So it knows it's going to find it within this directory, tag T, and then we'll just call the container name cyber quotes normal. And Docker will just basically leverage what we have in that Docker file to first part 1 is from this Docker image, right? Do all of these things, pull the image, all the details it needs, and then it's going to go to step 2, which is going to be that working directory, as you can see here, and then finally the entry point. So we see here, finally copying those files that we had within that directory. So now we can then run that container. So we can do that by doing a Docker run --rm cyber quotes normal. So what this does is it says Docker should start or run a particular container using this specified image. And the image we're using here is this cyber quotes normal, which we just built. And then this tag rm basically tells Docker we'll want to automatically remove the container if it exists. So let's go ahead and run this, and then we'll see it automatically generates a quote. This particular quote says there's no silver bullets with cybersecurity. A layered defense is the only viable option. This was said by James Scott, a senior fellow at the Institute for Critical Infrastructure Technology. If we run it again, it would give us another random quote. This one is from Bruce Schneier, who is a security technologist and author, and it says the internet is about to start killing people and the government regulates things that kill people. Let's put another one, maybe something a little bit nicer, hopefully. There's no parts for careless, greedy, or stupid. Chuck Norris, martial artist and actor. Okay, I don't know how that is a cybersecurity quote, but whatever. Now we know this particular container works whenever we run it. Now let's do a quick Docker images to see what we have here, and it is now registered as a image within our local development environment as this cyber quotes -normal. Now that we have it as an image, we can actually use Docker Scout to do a quick view on it. QV is a short form for quick view, so we could just do Docker Scout QV cyber quotes normal. This takes a little bit of time, so we have to wait a little bit for this to do the indexing and then do the analysis. If you're using a T2 micro, it might not work, but a T2 medium will definitely be able to handle the workload that is required to do this. So let's wait a little bit for this to actually do the indexing and then run the analysis using Docker Scout. All right, so it took about 2 minutes or so, and it ran the quick view on the cyber quotes normal image. Now remember, this particular image that we created, or this application that it was built for, is based on a Python 3 image, right? So based on a very simple Python image, and we can see that the base image, which is is Python 3 has 1 critical vulnerability, 6 high vulnerabilities, 3 medium vulnerabilities, and 114 low vulnerabilities. Same thing for the target image that, was created from the base image. So definitely a lot of vulnerabilities in this particular image. Now, the next step is actually to build the same application with the same processes using a secure ChainGuard image. Let's take a look at how that will look like. All right, so if we go back here, we can clear screen and we just cd out of here, doing ls, and let's navigate into the cyber secure folder, which basically contains the same 3 files: a Docker file, an app.py file, and a quotes.txt file. App is the same exact app, nothing changed with that. The quotes are also the same, but the Docker file changed. And in the Docker file, we're pulling the ChainGuard Python image, right? We're pulling the latest ChainGuard Python image and basically using the cyberquotes directory within this particular cyberquotes directory and copying those things into the container and then using this exact same entry point. All the same thing. Only thing that's changing here is we're using the ChainGuard image. So let's go ahead and clear that. And we're going to do the same thing. We're going to do a Docker build this directory, tag T, and we do cyberquotes secure as the image name. And this will basically do the exact same thing as the first one, but this time using ChainGuard's Python image. And that was even a lot faster. So let's clear this out and then let's go ahead and run it to see if it works. So docker run --rm cyberquotes secure, and we get another very alarming quote. Let's run it again to get something maybe better. Phishing is a major problem because there really is no patch for humans. Mike Densaglio, security professional. Okay, I don't like the way it's put. But that is that. Let's run it again one more time. The best way to predict the future is to event it. In cybersecurity, this means identifying and mitigating potential threats before they can cause harm. Alan K, computer scientist. Let's try it one more time. Let's see if we get anything nice. Privacy is not for the passive. Jeffrey Russin, law professor. Okay, cool. We've got all the nice quotes and everything. It runs as we want it to. Let's do our Docker Scout quick view again. So Docker Scout QV. This time we're going to use the cyberquotes secure. Let's do another Docker images again. So let's see how many images we have now that we just did the cyberquotes secure build, and we see we have the cyberquotes secure and cyberquotes normal. We have the ChainGuard Nginx one, and we have the Nginx one that is from Docker. The normal cyberquotes one is super big, like with that base Python image for 1.2 gigabytes. That's insane. Let's go ahead and do a Docker Scout quick view on our new cyberquotes secure one that's a lot smaller and runs, just as smoothly as the first one. So let's do a Docker Scout QV cyberquotes secure. This should probably take less time than the first one because it's a much smaller image. All right, there we go. And it comes back with 0 critical, 0 highs, 0 mediums, 0 lows. And obviously we saw it ran just as easily as the first one. Let's also do a comparison. So we're just going to do a Docker Scout compare. Let's compare the cyberquotes normal one to cyberquotes secure, comparing those 2 containers. And I should have probably piped that into less just to make it easier to read. All right, and we see that again, it's the regular Python image has a ton of vulnerabilities, and the secure one from ChainGuard has no vulnerabilities at all. It's much smaller, has fewer packages, and runs just as well as the other one. All right, now this is all fun. We are going to need to clean up our environment here, so let's just go ahead and just cd out of here, and we're just going to exit this connection. And in order for us to clean this up, we're just going to do AWS CloudFormation, delete stack name, ChainGuard demo, and then my profile havoc, and then we're gonna just wait for completion. So just say CloudFormation, wait, stack, delete, complete, stack name, ChainGuard demo, profile havoc. And then this will just wait until the stack has been deleted for us to know when it's fully deleted. All right, that took a little bit, but it's now fully deleted. All right, so as we saw, using secure base images like those provided by ChainGuard helps ensure that our applications are not only functional and lightweight, but also secure, thereby reducing the risk of vulnerabilities in our software supply chain. This was definitely a fun weekend project, learning more about ChainGuard, but also Dockerizing a simple Python application, which I plan on developing into a fully production-ready app. Of course, deployed using a ChainGuard image. So keep an eye out for more videos about that. And again, thanks to ChainGuard for making this video possible. I hope you learned some cool things with this tutorial as we went over some stuff from CloudFormation to AWS CLI to some bash scripting to some Python, some Docker, and of course, obviously some security stuff. Be sure to reach out in the Discord if you run into any issues, and I'll be happy to help you out. We'll put a link in the description below. And also, if you enjoyed this video, you'll definitely enjoy this one where I go over another DevSecOps scenario showing you how an attacker can perform an indirect poison pipeline execution attack in a Jenkins CI/CD system, or this other video where I show you how to set up your own Kubernetes hacking lab. Thanks for watching, and I'll see you in the next video. Bye-bye.